Hello, this is the Worksheet A for the Vatilo House located in Birmingham, Alabama. There's a few things that you'll need for this calculation. I have the original blueprint, the original J1AE, and the original worksheet. I also have Table 1A, Table 10A, and the Vatilo House that I'm going to have located in Birmingham, Alabama, J1AE, and the Worksheet A. So let's just get started with the Worksheet A. Okay, this is a filled out form that I created just so I can easily put the numbers in that we're going to be doing. Now, this is Worksheet A and Worksheet B together. Like I said, you can find it in your files. I've already named the project Vatilo, and of course this is Birmingham, Alabama. I've also put this up at the top, so when I'm switching back and forth between worksheets, you'll know the difference. Like I said, this would be, the blue would represent where it's originally located in Gulf Coast Town, Texas, and of course we'll be doing Birmingham, Alabama. So we're just going to get rid of this one for right now, and we're just going to focus on this one, and I'm going to zoom in a little bit here so we can see it a little bit better. This is the worksheet A and B. Like I said, the A part, this is what we're going to be doing, just this part up here located at the top. This part down here is windows. That'll be the next video. Okay. So let's bring that back down, and let's make this where we can see a little bit better. Okay, there we go. All right, so the easiest way to do this is always start from left to right and just plug in the numbers where they need to be plugged in. Now, to kind of help you out, the numbers that are in red will represent things that are heating, and the things that are in blue will represent things that are in cooling. Okay, so we'll just start with this. Indoor design conditions. Heating dry bulb. This is the number that you want your house temperature, internal temperature, to be in the winter time or in the heating season. So this will be 70 degrees. Okay. And outdoor design conditions would be the next thing. And then the next thing you got over here would be cool and dry bulb. So for winter humidification, we don't need any humidification for the winter time right now for this house. So we're just going to kind of go across this line right here. Cooling dry bulb. This is the temperature you want your house to be when you're cooling. ASHRAE defines this as 75 degrees for energy efficiency. Okay. All right. Okay. Cooling relative humidity. This is also another ASHRAE recommendation. Like I said, 50% relative humidity is the midpoint. You can have 45% relative humidity, or you can have 55% relative humidity. Those would all depend on client allergies, humidification needs, if they have a lot of plants or something like that in the house, and everything else. Okay, so now we need to go to Table 1A. Table 1A has all the information that we're going to need for this part right here. I'll zoom in here a little bit. There we go. Now we can see it, and we can get rid of some of this down here and scroll up where we can see what we're talking about. Now, Table 1A has your location. Basically, you pick a location that is closest to where we're going to be at. Now, of course, we're doing Birmingham, so we're going to be Birmingham, Alabama. Elevation is how high up it is. Latitude degrees north. If you cut the world at the equator going northernly, like so, this would be how far above the equator it is. Heating outdoor dry bulb is your 99% dry bulb. It means 99% of the time in the wintertime it is above this temperature. 1% dry bulb, 99% of the time for the last 30 years, it hasn't got above 93 degrees. Coincidental wet bulb, this is at that temperature. This is coincidentally what the wet bulb would be at that temperature. Grains differential, 55%, 50%, and 45%. You generally want to use 50% relative humidity as your standard. And of course, daily range is the temperature range between the daylight time temperature and the nighttime temperature. So like Birmingham, Alabama here is a medium. That means it's not too far apart. It's probably less than 20 degrees. So it'd be 90 degrees in the day. It's probably not going to get below 70 degrees of the evening. And the HDD, CDD, 50 and 65, this is an energy efficiency ratio. Like I said, for when they're calling for cooling above and below certain temperatures, 65 degrees for there, 50 below when you're heating. So cooling and heating, like I said, they're pretty much saying like this heating one. Pretty much anything above 65 degrees, most humans are in cooling mode. They're not going to be in a heating mode. And of course, below 50 degrees, most humans are going to be in a heating mode, not a cooling mode. So this is a ratio of energy and from ASHRAE and other engineers. So now we're just going to take these numbers and we're just going to place them where they need to go on our actual form here. So first one we got, feet in elevation, 630. All right, let's see, elevation right here. So our elevation, and I'm going to slide this down just enough that I can get to both of them. We can see both of them. So 630 is going to go right there. Now I do recommend putting a decimal point and a zero behind it just to keep things clean, and so that way you know where you're at. For most of these calculations, just like this one right here, we will go to the thousandths place. So like I said, once you've done your calculation, always round to a thousandths place. So that's our feet elevation. Latitude north is going to go right here. It's 34 degrees above the equator. Heating, 99% outdoor dry bulb. Heating outdoor dry bulb, 99% is right here. So we're going to put 24 degrees. And our 1% dry bulb, which this should be cooling, is going to be 93. And I'll go ahead and adjust that right now. Change that to blue. There we go. Now let's go ahead and put that decimal point in these so we keep it clean. Okay. Drains differential. So our drains differential, like I said, this is the amount of moisture or humidity we'd have with the cooling and everything else at 50% relative humidity. So we're going to go with 39. 9.0. Our daily range for here is medium, which I already have that in there for medium. All right, the last thing we got to do is altitude correction factor, and then do this calculation right here. So on all these worksheets, basically you just kind of read across what it says, and it says for heating temperature differential, or HTD, equals indoor dry bulb minus outdoor 99%. So our indoor dry bulb is right here. Let's see, 70 minus 24. So this is where your calculator comes into play, and I've got the little paper pad here down below it so it kind of keeps a track on there. So 70 minus 24 degrees, we get 46 degrees. So our HTD will be 46 degrees. Okay. All right, for our cooling temperature differential, it's reverse. It's going to be the outdoor 1% dry bulb minus the indoor. So in other words, our indoor temperature that we want and our 1% dry bulb. So we're going to take this number here, we're going to subtract this number here. So that'll be 93 minus 75, and we get 18. 18 HTD. Okay. Our final thing that we have to do is table 10A altitude correction factor. Now, an important thing to know on this is get your elevation in feet. Your elevation in feet is going to help you do this calculation very, very simply. So let's go to table 10A. So here's table 10A. And as you can see, it starts from sea level and it goes upward from sea level. And altitude correction factor starts at 1, and as it goes up higher, you see this number gets lower. So as this number is getting bigger, this number's getting lower, and so on and so on. And basically, like I said, this is air. You know, how dense air is packed into an area. This is basically a correction for that. So there's a simple calculation right here. Let's just zoom in on that. 1 minus 0.00000308 times the feet. Well, our feet was 630 feet, elevation right here. So 630, and let me get my little paper up here. Let's get that up here where we can see that. Okay, 630 times, once again, this number right here, 0.00000308. Okay, so we get 0.019404. Just keep that number right there. Now it says all you have to do is take this number we got, this 0.19404, and subtract it from 1. Because we're going upwards, right? We're not at 1,000 feet, which is 0.97, but we're not at sea level either. We're above sea level, but in between here. So we're right in between these two numbers right here. So we'll just take 1.0 minus 0.019404, and we get, this is your altitude correction factor number. Now, like I said, if we was at 1,000 feet, it would be 0.97. So we're in between here and here. So this seems correct. Now, all we got to do is just kind of round out. Like I said, always go to the thousandths place. So we got the tenths, hundredths, thousandths. So that rounds that up, which rounds this up. So this would be a 6 right off the bat. So that's going to round this up to 1. So our altitude correction factor would be 0.981. Okay. And there you go. That is all of the Vatilo House for Birmingham, Alabama altitude correction. Of course, you can use this same house and locate it in a different location, but if you use these exact same steps, you should be able to complete Worksheet A, which this is it right here, Worksheet A. You should be able to finish Worksheet A. Now, it's very important that you get these numbers correct right off the start, because these numbers here are going to transpose onto every other correction factor worksheet you have on here. So make sure you have these numbers, and you'll use CTD, HTD, indoor cooling conditions, heating conditions, even the altitude correction factor. You're going to use these later in the worksheet, so make sure that you do these correct and you get these right. All right, the last thing you have to do is just transpose these over to your master worksheet, which is the J1AE. This is the master sheet. This is where everything goes. As you can see, I already got my indoor heating and cooling right there, already put on there. So we're just going to kind of zoom in a little bit here so we can see a little bit better. And we're going to take this and scoosh it, maybe. There we go. Get it where we can kind of flip between these two right here without having to flip back and forth too much. All right, first off, make sure you have the correct location. So this is the Vatilo House, and the location is Birmingham, Alabama. If you want to put airport, that's fine. That kind of keep you on target. So now all we got to do is just go in here and fill in these parts right here. Now, Worksheet A basically fills in everything right here. There's your altitude correction factor. There's your indoor heating, latitude, daily range, all that. So let's just transpose these numbers over here where we can actually see them. And I'm going to pull this one down and put this one up here, so that way we can just transpose without having to click back and forth. All right, so we'll just start here. There's your heating dry bulb temperature, 70 degrees. Cooling, 75 degrees. Indoor RH, relative humidity percentage cooling, so we're going to be 50% right there, so this will be 50%. 50%. Okay, our elevation is 630 feet right here, so this number here will go right here. 630 feet. Okay, our latitude is right here, 34, goes right here, 34 degrees north. You can put north on there if you wanted to. Daily range is right here, it's medium, so daily range will go right here. Let's kind of straighten that up a little bit. There we go. All right, 99% dry bulb, ours is 24. Our 1% dry bulb is 93. Our grains differential for 50% relative humidity is 39. Our HTD is 46 degrees. There we go. And our coolant temp differential will be 18. Okay. And there you go. Like I said, you have completed the first part and transitioned up. Oh, altitude correction factor. Let's make sure we get everything on there. 0.981. There we go. Now we got all our boxes checked now. Yes. Okay. So there you go. That's the worksheet A, and transposing it over to J1AE. Remember, this is the J1AE, and this is worksheet A and B. I highly recommend you do the worksheet completely first on everything that you need to do, then transpose over here to the J1AE. It'll make things a whole lot simpler and cleaner, especially when you get to Windows, which will be our next video. But this should set you up, and remember, this needs to be correct because a lot of your other calculations are going to come off of this based off of these numbers right here. So if you put a decimal point in the wrong place, if you scribble a number, you know, try to keep your work real neat and clean so it can be read and everything. Okay? Thank you.